Welcome to the week 1 live session for intermediate algebra 1033. So what I'm going to do in this week 1 video is go over a little bit about how the course is set up and then what the assignments are like, and then I'll talk about some math concepts and explain them. So every week in these live sessions, which I recorded, I try and take a look at the quizzes and the tests to see what you're going to be experiencing this week and explain the concepts for you. But you also have YouTube. YouTube videos are great. You can go and search for any math concept, and also khanacademy.org. And excuse me if I'm clearing my throat a lot. I just can't help it. So the main assignments in this course each week is that you'll have a quiz, a test, and bonus points. That's what's consistent each week. In week 1 and 4, you have a little bit of extra stuff. So in weeks 1, you have an intro discussion, there's a regular discussion, there's a summary discussion, and there's a live session. And those are really optional. And then you also have a pre-test certification quiz test. Just a bunch of stuff. So in any course, if you go in the grade book, you'll see what is required. If you see other things around in the course, those are not required. If you want to know what's required for a grade, you go in the grade book. So the pre-test is required in the certification, and the quiz and the test, these are required. So I'm going to skip to this one first. Regards to the discussions and the live sessions, you'll see in the grade book there's a bonus points column each week, and you can get bonus points by participating in one of the discussions and or attending the live session or watching the recording. So any one of those is fine with me. And then I wanted to show what the difference between the quizzes and the tests are. So the quizzes and the tests are taken in Blackboard, and we have a database of problems that they pull from. So no two students have the same quiz exactly, for example, but there's a whole database and the questions will be similar. So everybody's quiz and tests has 25 questions, and they're multiple choice. I think for the most part, I think sometimes it'll be true false. On the quizzes, you get unlimited number of attempts. On the tests, you get 1 attempt. On the quizzes, there's no clock. On the tests, you have 3 hours. I don't think anybody's ever needed more than 3 hours. But the thing I want to emphasize here with the quizzes is, since you get an unlimited number of attempts, that's like a gift. When you're a student in college, you don't see that enough. And so you want to take the quiz each week over and over until you get a 100. If you get a 100 the first attempt, great. But I'm talking about if you even miss one, go study that problem and then retake it. And I don't care how many times it takes for you to get that 100. Keep retaking it until you get a 100. Because when you come to the final exam at the end of the course, you're going to be so glad that you gave yourself that cushion in your grade. Make it where the points that you miss are not from laziness and not taking advantage of these opportunities, but the points that you miss in a course, especially, something like math, are for where you miss something on problems that were actually difficult for you. So you grab up every opportunity. So we have, a little bit of bonus points, and then with each quiz you should be getting 100. And then we have my math lab. This is where you can see the text pages. I don't know of any student that's ever been concerned with seeing the text pages. That's an ancient way of doing school. So if you buy my math lab, which is optional, you can see the text pages there, but also you have a lot of problems there that you can practice. And this is what it looks like. So in the announcements, I have my math lab info announcement, and that'll help you to learn how to register and what give you the information you need to register in my math lab. But once you're in there, you're in our course, you'll see this page. So what you do is click on assignments on the left, and that'll take you here. and you'll see week 1 at least, and you can click on that, and then you'll see a whole bunch of problems here. So you can click on any problem or do all of them. It's all optional. And this is what a problem looks like. So you type your answer in here, and then you click on check answer to see if you're correct or not right away, no matter what time of day that you're practicing. And then if you need, you can click on help me solve this button, click on view an example button, and I think there's some other things here, including the text pages. So you have a great resource there, and students seem to love this. This course is actually for 0020, but don't mind that. If you follow the information in the My Math Lab announcement, you'll be registered in our course. So My Math Lab's optional, but it's a really great way to go and practice. So you can go and practice certain problems that you want to practice rather than others at all, or you can do all of them. It's up to you. So you can really drill and practice and get the help you need. So these are the first problems that we'll talk about this week. Adding and subtracting integers. I'm sorry for clearing my throat. I'm going to be doing that a lot. Getting over a certain cold. So if we have -9 plus 2, now see the nature of these problems. Maybe you've seen this before. If you know of a way that you visualize doing these, or a procedure that you do these and you're always getting them correct, then stick with that method. But there's a few ways that teachers will teach this, and you have to find a way that you like. So I'm going to do this or present it in a way that I've seen students never get them incorrect, and they just always get them correct, and it reduces chance of error. So with -9 plus 2, this is how I want you to think about it. If you can stop and remember this. Think about this in terms of money. So if you have -9, that means you're in debt $9, and then you add 2 to your account. Where are you at? You're still in debt, and you know it's $7. So you should try these. You could pause the video and try them, and then I'll explain them, and you can see how you did. So with -3 minus 5, it's like you're in debt $3, and then you spend $5 more. So you're really in debt $8. So for this one, when you see a problem like this, first of all, this shouldn't be happening. See how this problem's like that too? We're going to resolve those signs, what I call resolve or evaluate those signs. When a plus and a minus is next to each other, a negative always wins. Let's see if my internet will let me write what I want. So -20 minus 5. This is how you should write the problem. Never ever leave it like this. This is something to clean up. And so now you're in debt $20, you see? And then you spend $5 more. So you're really in debt $25. So for this one, we have 2 minus 18. So 2 is positive. That means you have 2 in your account. And then you spend $18. So you know you're in the negative, $16. And then with this one, we need to clean this up. So positive and negative are next to each other. Negative always wins. 15 minus 3 is what you're looking at. And that's more straightforward kind of problem that we're used to. So that's 12. And so that's the first types of problems that you'll see in this course. Next will be multiplying and dividing. And so we have -5 times -3. And so that equals positive 15. And then here you have -10 divided by -2. Negative divided by negative is a positive, so 10 divided by 2 is 5. So the big thing to remember with these kinds of problems, you'll have to know your multiplication tables, but also remember that positive times positive equals a positive. You must know these very, very well, have them memorized. And there's just a few of them, and there's some patterns, so it's not very difficult. Positive times a negative equals a negative. Negative times a positive equals a negative. So these, remember those. So when the signs are the same, a positive always wins. When you have one of each sign, a negative always wins. It's the same thing with division. Positive divided by positive equals a positive. Negative divided by negative equals a positive. Positive divided by negative equals a negative. Negative divided by a positive equals a negative. Write these down on a piece of paper or a 3x5 card and look at them. Just look at them and think about it and register the pattern in your head. Very quick. Once or twice a day. Monday through Friday. Take a break on Saturday, and then on Sunday test yourself. See if you remember it. That's the way to get these into your short-term memory, from your short-term memory into your long-term memory. And it's very, very important, and it's not hard to do that. You know, tape the piece of paper up on the mirror by when you brush your teeth or looking at it or something. It's very important to get this in your long-term memory so you can build onto this knowledge, because we will certainly be building onto this really quickly. And you want this back in there so you can build onto it. Trust me, I've been teaching for quite a while. That's the great thing to do. Next thing we're going to do is review the order of operations. So P is for parentheses. And so operations are like add, subtract, multiply, divide. And we have parentheses, exponents, multiplication, division, addition, and subtraction. And the math gods gave us parentheses, these order of operations. So the certain order is the way we'll get problems correct, especially expressions. I suppose we use this in equations too. So P is first, so parentheses are first. We'll do some examples using these too. E is for exponents, so then you move to exponents and evaluate any of those. Now, multiplication and division come together. That's the thing that's unfortunate about PEMDAS, this acronym that we use. It doesn't mean multiplication's first. This means multiplication and division comes next. From left to right. Whichever comes first from left to right. From to right. This is what happens when I talk and try to write at the same time. From left to right. Okay? Doesn't mean multiplication's first all the time. If you have division first, you do that. Same thing with addition and subtraction. So we do the multiplication and division before addition and subtraction. But once we get to the addition and subtraction, you do that from left to right as well. So addition's not always first. Okay? So sometimes subtraction will be first. So here's an example. Simplify -5 plus 9 minus 6 times 2. So first of all, you write the original problem down. I want to teach you how to write math work correctly. So I want to see this in your discussion posts as well. I'm going to correct if anybody who needs it on how to write your math work. This reduces chance of error. So first of all, we've got addition, subtraction, and multiplication. We have to do multiplication first, so I like to underline that. Now I'm going to write right under this expression what this expression now is going to change to. 6 times 2 is 12. So now this is what this expression changes to. I don't take 6 times 2 right in here equals 12 and put that in there. No, I just replace that with this. Now I'm looking at what's next. So we have addition and subtraction. And we have to do this first because it's from left to right. So -5 plus 9. So that's a 4 minus 12. So that expression becomes this now, and 4 minus 12 becomes -8. So there's your answer. So your work should look like this. Write down the original problem, evaluate one thing at a time, show how the expression changes all the way down to the answer. Here's another one. So we have 6 minus 2 squared plus 18 divided by 3 plus 4 squared. So first we look for parentheses. There's no parentheses. Next thing's exponents. So I'm going to underline these two. That's what we do next. So I'm going to write down every other number and symbol and replace those exponents with what they're equivalent to. So 2 squared is 4, and I have plus 18 divided by 3 plus, and 4 squared is 16. So now this expression is this. And now we have subtraction, addition, division, and addition. So division comes next, so I underline that for myself. And I know 6 minus 4 is 2. I see that. I'm not going to evaluate it one thing at a time. I'm going to do one thing at a time. 18 divided by 3 is 6, so that gets replaced by 6. So I can see, my brain needs to see what I'm looking at here. So now I have addition, subtraction, and I have to do this first. So that's 2 plus 6 plus 16. And then this is next, so 8 plus 16. And that makes 24. Okay, this is how you do problems correctly every single time. Or write down the original problem, evaluate one thing at a time in each step. I evaluated both exponents because they don't affect each other. So I went ahead and did that in one step. And you're not taking parts of the problem, writing it in here. If you need to go over here and figure out what 18 divided by 3 is, you do that over here, way over to the side. But this is how to write math work correctly. Now we'll start to look at multiplication and with some algebra and unknown variables. So here we have 3 times x minus 4. So we use what's called the distributive property, and that means to share this 3 to each term inside the parentheses here. So 3 times x is 3x. That's what we do when we don't know what x is. And 3 times negative 4 is negative 12. So that's the answer for this problem. So if you are comfortable, you can pause the video and try these and then see how you did. So now with this we have negative 2 times negative 3 plus y. So negative 2 needs to be distributed to each term inside the parentheses here. So negative 2 times negative 3, that's a positive 6. Negative 2 times a positive y is a negative 2y. And that's the answer. Now for this one we have negative times x minus y minus 1. We have to remember that there's a secret negative 1 right there that we have to distribute to each term inside the parentheses. So that will become negative 1 times x, which is negative x. Negative 1 times negative y, which is positive y. Negative 1 times negative 1, which is plus 1. And that's it. So for this one, we have a little more going on. So remember, we start with the order of operations, which is parentheses. Now this is a z, and this is a 2. See how I write my z's to make sure they don't look like 2's? I put a line through them. That's a good habit to do. So these are unlike terms. We cannot combine them. So we skip the parentheses step. And there's no exponents. So what's next is multiplication or division. Well, this is multiplication here, where we have to distribute or multiply that 3 to each term inside the parentheses. So this is going to come down. Then we have 3 times z, which is 3z. Then 3 times negative 2, which is negative 6. And then this z comes down as well. So I'm just showing how my expression changes in each step. Now what I do is look for like terms, like this 5 and negative 6 are alike. And then these are z terms here that I can combine. So 5 minus 6 is negative 1. 3z plus that 1z is plus 4z. So if you're going to have multiple choice, you just look for the multiple choice answer there that corresponds to that. So in this problem, it's a little bit more complex. Multiply 3x squared times 5x to the third minus 2x minus 1. See if I can use some other color. So 3x squared needs to be distributed to each term inside the parentheses because all those terms inside the parentheses are unlike anyway. Cannot combine these. This is an x to the third term. This is an x term. This is just a number. So now we look at 3x squared times 5x to the third. What we do is the 3 times the 5, which is 15. That's going to be x to the something. And this is where it's kind of funny they put these problems in week 1 because I think it's in week 2 that we start to look at exponents. But when you're multiplying x squared times x to the third, you actually have 2 x's there and then 3 x's. They're all being multiplied together, and that's really x to the fifth. So you can just add those exponents. So this is 15x to the fifth here. And then 3x squared minus 2x gives you negative 6x to the third. Do you see how I got the x to the third? There's a 1 right here, 1x, and there's 2 x's here, so we add those and that makes 3. And then 3x squared minus 1, or times minus 1 is a negative 3x squared. Now this is an x to the fifth term, this is an x to the third term, this is an x squared term, and that's it. They're all unlike, can't do anything else. So that's it, we multiplied that. Now here's another problem. You look within parentheses to see if you can combine these terms, and you cannot. They're not alike. So the next thing is we have to recognize this negative 1 right here that we multiply to each term inside the parentheses. So I want to show what this expression becomes now in the next step. 9x comes down. We have negative 1 times 2x, so that's negative 2x. Negative 1 times negative 5, that's plus 5. So now our expression looks like this, and we see what we have. We have like terms right here. So 9x minus 2x, that makes a 7x. Then you have plus 5. So 7x plus 5 is your answer. Here's another problem that you'll see is a bunch of, algebraic terms, and you pretty much have to look for like terms. So the exponent kind of names the term. This is an x squared term. This is an x term, this is a number. So here's an x squared term and here's one. So you can use different colors if you want. So here's an x term and here's an x term, so we'll combine those in a minute. And then here's a number and here's a number, and we can combine those. So if we combine the x squared terms, we have 5x squared minus 3x squared, so that's 2x squared. And if there's a lot of terms, I cross them out to make sure that I know that I use them. Negative 5x plus 9x, that's a positive 4x. So I've used those. Then I have 7 minus 4, which is positive 3. So I can see I used everything. And that's it. This is your answer right here. The next problem, I've got a couple like this. I've got a bunch of algebra terms here that we got to combine, but we're subtracting. So if you get a problem with a plus, that's kind of easier. It's not a big deal, but the ones with subtraction are ones that students miss so often. So you really need to pay attention to what I'm going to point out here. So this is like, when we have a bunch of terms like this, we just call it a polynomial. We're basically subtracting one polynomial from another polynomial. And these parentheses are really never needed. So I'm going to write this here without parentheses. Okay, so that's it. Now here, we have to be careful because there's that secret minus 1 that we have to distribute to each term inside the parentheses here. Because we're subtracting more than one term, subtracting a few things, so we have to go ahead and change the signs. So now negative 1 times 2x to the fifth is negative 2x to the fifth. Negative 1 times 5x to the third is negative 5x to the third. Negative 1 times negative 7 is plus 7. Now we can see what we have here and look for like terms. So here's an x to the fifth term, and here's one. Then I have an x to the fourth term, which will stay by itself. And then we have x to the third terms right here and here. And then we have just numbers right here. So using colors might help you to identify things. So with our x to the fifth terms, we have 1x to the fifth minus 2x to the fifth. So that's negative 1x to the fifth, but we don't really write that one. So it's like a 1 minus 2 is a minus 1. So I use those, and then I gotta carry down that negative 2x to the fourth term. And then we have 3x to the third minus 5x to the third, and that's negative 2x to the third. Then we have negative 1 plus 7, which is plus 6. So that's it. There's no like terms to combine, so that's it. Here's another one like that, and if you want to pause the video and try that, that's a good idea. Because we have subtraction right here, we have to watch that when it's a subtraction problem. So there's no parentheses needed on the first set, so I'm just going to copy down all of these terms. Now with this subtraction sign, we have to remember there's a negative 1 right here that we have to distribute to each term inside the parentheses to the right of it, especially because there's more than one term. So negative 1 times 5y to the third, that makes negative 5y to the third. Minus 1 times negative 7y is plus 7y. Negative 1 times negative 1 is plus 1. So now we look for like terms. Here's y to the third terms here and here. We have a y squared term by itself. Then we have y terms that are alike. And then we have numbers here. So we have 3y to the third minus 5y to the third. So that'll be negative 2y to the third. Then plus 2y squared. Then you have negative 5y plus 7y, so that's plus 2y. And then you have negative 1 plus 1, that's just, they cancel each other out. They add up to 0. So this is your answer, that's it. That's what you should find in the multiple choice. Now for this kind of problem, we have 5x plus 4 when x equals 2. So what we do is write down our expression, and we're given the value of x here. So we need to evaluate this expression when x is 2. So if x is 2, I'm totally going to substitute 2 in for x. When 5 and x are sitting next to each other like that, that's multiplication. So I'm going to designate multiplication like that. So you see I substituted 2 in for x. Now I know we do multiplication first, so I have 10 plus 4, and that makes 14. So the answer is 14. Now here's another one. So I'm going to, consider this already written down. I already wrote down the original problem. Now I'm given that x is negative 1. So I have to plug in negative 1 everywhere I see an x. So 5 times negative 1 squared minus, and here's where the x is, so I put negative 1 in for that, and then minus 7. See how I put a line through my 7s so they don't accidentally end up looking like 1s? That's a good habit as well. So I plugged in negative 1, totally substituted negative 1 in for x. Now I'm going to evaluate. First thing to do is exponents. So negative 1 times negative 1 is just 1. So that would be 5 times 1 minus 1 minus 7. Now we can do a couple things maybe at the same time. So multiplication makes this a 5. When you have two signs next to each other, negative and negative, a plus wins. So we have 5 plus 1 minus 7. So this will make 6 minus 7. And then the answer is negative 1. Ironically, because even though we're given the value of x is negative 1, the whole expression just happened to work out to negative 1. Now for this problem, we're given 9a minus 7b, and we're given the values for both a and b. So what we do is plug in our value for a, which is negative 10. So 9 times negative 10, the minus sign, the 7, and then b is 3, so we substitute 3 in for b. So we have multiplication here to do and multiplication here. So 9 times negative 10 is negative 90, and then negative 7 times 3 is negative 21. So then we just consider adding these numbers as if we had spent $90 and we spent $21 more. We're in debt negative 111. Here's another problem, but it asks in this form, is x equals 3 a solution to x squared minus 3x plus 6 equals 0? So what you do is you take that equation and write it down, and then we're asked, is x equals 3 a solution? So what we do is we're going to plug in 3 everywhere we see an x, and we're going to see if we get a true statement. So first we have 3 squared, which is 9. So I evaluate exponents first. And then we do multiplication next, so that's 9 minus 9 plus 6 equals 0. And we have to do addition subtraction first from left to right. So 9 minus 9, that makes a 0, plus 6 equals 0. So I'm going to take that up here. So that makes 6 equals 0, which is not a true statement. Since we have that 0 on this side, it should work out where 0 happens on the left side. But we get 6 equals 0, which is not a true statement, so the answer is no. X equals 3 is not a solution to that equation. So that's how you do those problems. Now we start with equations. We were working pretty much with expressions all this time. Now what we're going to do is take a look at 5x plus 10 equals 3 and solve this. What this means is we're going to rearrange this thing so that x is by itself, so we can find out what value that x represents. So in the end, we want to know, what is this number value that x represents. So what you're kind of looking to do is get the 5 away from x over to this side so you can combine it with its like term here, and also the 10 away from x. And we use what's called the properties of equality. So we start with the number kind of farther away from x first, and we'll do a few of these, and I'll repeat these things a lot, so don't worry. So I want that 10. I'm going to start with the 10. I want it to disappear from the left side and appear on the right side, so I can combine it with the 3, because it needs to go away from the x. So I can make it disappear if I subtract 10. And if I subtract 10 on that side, I've got to subtract 10 on this side. And the way it disappears, that 10 minus 10 is a 0. 5x plus 0 is really just 5x, so 5x is left by itself. And then we go ahead and evaluate 3 minus 10, which is negative 7. So that way I got the 10 to disappear from that side and appear over here, and I combined it with this. So it's within here. Now I need the 5 to go away from the x. So 5 is being multiplied by x. What I'm going to do is the opposite operation and divide by 5. And if I do it on the left side, I have to do it on the right side. That's called the property of equality. I'm not changing the equation at all if I do that. what happens is these 5's cancel because 5 divided by 5 is 1, and 1 times x is just x. That's how we get x by itself. And then this is a fraction that's actually reduced, so negative 7/5. So x is negative 7/5. And you'll look in the multiple choice for that answer. So replay that if you need to see how that works. And so now we have another equation. We need to solve for x. So first of all, what we do is look at where the equal sign is. It's right here. And then we look to see if there's any like terms on the same side of the equal sign that we can combine. So like these x terms here, we can go ahead and combine those. And these numbers here, we can go ahead and combine those. So on the right side, we'll still have 2x minus 1. So 9x plus 2x, that's 11x. And then negative 1 minus 10, that's negative 11 or minus 11. So now my equation looks like this. So remember, what we want in the end is to see the value that x equals. So we need to get these like terms on the same side of the equal sign so that we can combine them. There's literally at this point 4 different things you could do, and you'd be correct. If your algebra is correct, you'll get the same correct answer. So what I'm going to do is I'll choose 2x. I'm going to choose 2x to move over here to this side, so I'll be able to combine it with 11x. And this is how I'll do that. I have to write down everything else that's in the equation. But I'm going to make that 2x disappear from the right side and appear on the left side. So you can think, how am I going to do that? So I'll subtract 2x. And since I'm doing it that side, I'm going to do that to this side as well. So what happens is 11x minus 2x is 9x. And then we have minus 11 equals. And 2x minus 2x is just 0. 0 minus 1 is just minus 1. So that's how I got that 2x to disappear from the right side and appear on the left side. And I combined it with the 11x. Now here, remember, I'm working to get x by itself. So I want the 9 away from x and I want the 11 away from x. We start with the number sort of that's farther away first. So I'm going to make the negative 11 disappear from the left side and appear on the right side. So you can think about, how am I going to do that? So if I add 11, that'll be good because this will be 0. But I got to do that to this side too. And then I'm going to bring my work up here. So what I have is 9x minus 0, essentially, and that's just 9x. So now 9x is by itself, which is good. Equals, and negative 1 plus 11 is 10. So now 9x equals 10. So I need the x to be by itself. That 9 needs to go away. Since it's being multiplied by x, I'm going to do the opposite operation, which if you see, I usually do the opposite operation going on. But whatever works, because you want that 0 to happen, like here, 0. So I chose to add 11. And I chose to subtract 2x because I need that 0. Here what I need is a 1. And so 9 divided by 9 is 1. 1 times x is x. It's not going to help if it's a 0. I can't quite, if I do negative 9, well, that's just not going to make a 0. I need to get rid of, since there's multiplication between these two, I need to do the division. So 9 divided by 9 is 1. 1 times x is just x. And then on the right side, you can see the answer is just 10/9. We don't make that into a mixed number. We pretty much don't see mixed numbers anymore in math at this point and up. You can look in your multiple choice, though, to see what the answer is like. Now we have this equation, and I have just a few more problems left to do. So the first thing we're going to do is distribute this negative 3 to each term inside the parentheses. So negative 3 times x is negative 3x. Negative 3 times negative 2 is plus 6 equals 2x minus 2. Okay, so now we kind of have a similar problem that we had before. We want to get these x terms on the same side of the equal sign so we can combine them. We want to get these numbers on the same side of the equal side because our goal is to get x by itself. So we need one x term. So one thing I'll do, I guess, I want to actually move the negative 3x over to this side. So I'm going to make the negative 3x disappear from the left side and appear on the right side. And I'll do that by adding 3x, because that's how I'll get that 0. So I need to add 3x here as well. So that makes 0. 0 plus 6 is just 6. So 6 is left by itself. And 2x plus 3x is 5x plus 2. So now I want the 2 to go over to this side so I can combine it with the 6. And how can I do that? If I subtract 2, that'll be 0, and that'll make that 2 disappear from that side. And take this up here. So 6 minus 2 is 4, and then I have 5x left here. So I need that 5 away from x. So you can remember what we did. Since 5 is being multiplied by x, gotta divide by 5, and gotta do that to both sides, because 5 divided by 5 is 1, which 1 times x is just x, allows the x to be by itself. So x equals 4/5. Now we have an inequality. Solving inequalities is very much like solving equations. There's just one big thing to remember, which is right here in red. So the first thing that we'll do, we have x minus 2 is greater than 9 times x minus 1. So what we'll get in the end is not x equals some one number, but a whole range of numbers. And so first thing we'll do is distribute this 9 to each term in the parentheses. So we have x minus 2 is greater than 9x minus 9. And again, it's just like working with an equation with an equal sign here. We want to get the x terms together and the numbers together on the same side so we can combine them. So I'm going to get rid of this x, I think, and move it to the right side. If you see what we have to remember with inequalities, solving inequalities is just like solving equations, except whenever we multiply or divide by a negative number, we have to flip the sign. And then our answer will be true. We found that we always have to do that, and then our range of answers will be true. So we have to just somehow try to remember that. So I wanted to move this x, so x minus x will make that 0. So I have to subtract x on this side as well. And so this makes 0, so negative 2 is left by itself, and we have greater than 9x minus 1x, that's 8x, minus 9. And so now I want this negative 9 over to this side. So I'm going to make that negative 9 disappear from the right side and appear on the left side. So if I add 9, that'll make 0 on this side, so that'll disappear on that side. So if negative 2 plus 9, that's a 7, greater than 8x. So far I didn't multiply or divide by any kind of negative number, so I don't have to flip the sign, and I don't have any negative numbers going on, so I know I'm not going to have to flip the sign in this problem. But basically you're going to divide both sides by 8, right? So you just do that. So x is less than 7/8, or you can turn it around this way. As long as that symbol is still pointing at the x. And that's it. Now here's another inequality that's very short, but we're definitely going to need to remember that whenever we multiply or divide by a negative, we flip the sign. So here is where we have negative 5x is less than 15, and we need to get rid of that negative 5. Since it's being multiplied by x, then we're going to divide both sides by that negative 5. So we're dividing by a negative number. Anytime you multiply or divide by a negative number, you have to flip the sign. So now our sign needs to be pointed this way. And negative 5 divided by negative 5 is 1. 1 times x is x. And 15 divided by negative 5 is negative 3. So x is greater than negative 3. One more problem to go. So you might be given a graph like this, and then you'll be given multiple choice, and you're asked which one of these represents this graph. So what's happening here is it's all kind of messy. I wrote as neat as I could. This is a number line of x where you have all these numbers, and there's an open circle at negative 2, and it shows shading all the way to the right, and it goes on forever. So this means x values are greater than negative 2, but not including negative 2. So see these symbols here with the equal part? Those mean that we include the negative 2. So we know C and D aren't going to be it. So we can eliminate these answers because of this part. If it was a closed circle, then yes, we include negative 2. But this is an open circle, so we're starting at negative 2, and it's all solutions greater than that. So we need to decide whether it's A or B. So this one says x is less than negative 2. This one says x values are greater than negative 2, so it's definitely B. All values sort of points the direction that is shaded too. So that's what that means. So this inequality represents the graph here. So just remember the assignments that are due this Sunday night is the certification, the pre-test, the quiz, and the test. So you can see that in the grade book. So those are what's due. And otherwise, I'll see you in class.